minutes, so I'll go through a few examples with you. So please take note on the step and the requirements that you need to find out before you can draw a complete correct graph of polynomial. So I will just start with the first example. So let's say I have a function y equal to x cubed minus 9x. So how do we draw the graph? So your first step is make sure you factor completely. So we can take out the x. So we'll get x squared minus 9. So we know that the 9, we can put it as 3 squared. So from here, we can get x. So here will be x minus 3, x plus 3. All right, that is your first step. And then the second step, your first piece of information that you can find out from the function is that we can find out the x and y intercept. So we start up with the x intercept first. So to find the x-intercept, we will set the y equal to 0. So y equal to 0. So x minus 3, x plus 3. So do it one by one. So we will get x equal to 0. So next one, x equal to 3. And the third one will be x equal to minus 3. So we will have these 3 points, 0, 0, 3, 0, and minus 3, 0. That will be your 3x intercept. So next, we move on to find out the y-intercept. To find the y-intercept, we will set the x become 0. So 0, 0 minus 3, and here will be your 0 plus 3. So you can see that these two brackets actually multiplied with 0. So we get your y equal to 0. So our coordinate is 0, 0. All right, next, I'm going to put a graph on the right side here. So I will put the graph here. So this will be your graph that I'm going to draw after we have analyzed these whole questions. Okay, so label the graph. So we need to put out where is 0, 0, 1 here, 0, 3, 0 is here. All right, minus 3 will be here. All right, so we have labeled these three, including the x and y intercept. Okay, that will be your first information that you can find. The second information that you can find is known as 0 behavior. I just call it the 0 behavior. So I normally put in a table form. So we draw a simple table. So here we put 0. And the second column, we put something known as your multiplicity. So multiplicity, I just call it M. And the third one, third column, I will just call it the behavior. So in short form, it's just a 0 behavior, right? So what is 0? So as you can see, 0 here. So what it means of 0? 0 basically means the x-intercept. So 0 and x-intercept is the same thing. So we have 3, 0. All right, so 3, 0 we have. First one, 0, 3, and minus 3. So we put it there. So we have 0, 3, and minus 3. All right, so once we have get the 0 value, so we can find out something known as your multiplicity or M. So how do we get the M? Okay, the M basically we get it from the exponent of the factor. So you can see that the first 0 is here. The M on top here will be 1. So on top here all 1, 1, 1. All right. So in the other case means that the multiplicity is all 1, 1, 1. So, and then 1, as you all know, is an odd number. So odd number, right? And it means that the behavior that at the 0 at these 3 points will be crossing. So the graph is basically crossing over at the 3x value here. Right, so I label that cross. So the graph actually cross like a straight line because the value is 1. If it's odd number, not 1, it will cross like a curve. All right. So I'll just put there cross for all these 3 values. All right. So and then we can just put it on the graph there. So I'll just put a remark here because later I have to analyze it. So here is a crossing at this point. So here also crossing at this point and also crossing at this point. All right, that is the second information that we have find out. The third information that we can find is known as the N behavior. So the third one, so I just call it the N behavior. So how do we get the end behavior? So we need to analyze the function, this one, all right, the function. So from here, we have to get the power function. So the power function basically means the one with the degree. So this will be your power function. So it's actually y equal to 1x cubed. All right, according to the y equal to axn, if your a is positive, bigger than 0, and your n is actually a odd number, so we actually can get the end behavior is left side down, right side up. So we know kind of the ending part of the graph. So we know that this is your graph. So the ending part of the graph is, we know that it start here and will end here. All right, I think we can actually complete the whole graph already, because with these three information, we can actually finish the graph. So I repeat again, so you need to find out these three pieces of information. The first one is your x and y intercept. The second one is they call it the zero, the multiplicity, and the behavior. The third one will be the end behavior. So with these three, the information will be sufficient enough for you to complete the graph. So we're actually finishing the graph. Okay, so we know that we will start here, and here is crossing over. So crossing over, we have two types. It can be this line that cross down or this line that cross here. So we know that start here, of course, it will be cross something like this. And you go up, of course, you have to come down because you have to cross down. So of course, it will cross like this. And you come down here, of course, to come up because it end up here. So you have to cross here also. So right now, we will just polish the graph and draw nicely. Remember, a polynomial graph must be smooth, must be continuous. So any sharp corner is not allowed. All right, so we just complete the graph here. So here will be come down. This is sharp corner, so cannot. So make sure it's smooth like this. Okay, come down and then here go up. Yes, and then complete finishing here. So some student, this part may draw it very tall. You can draw it very low. It doesn't matter. Here also the same thing. You can draw it up here. You can draw it down here. Also doesn't matter. So we actually can check one more last thing. This one is for you to double check, because the last piece of information we can find is from the degree. We know that it's 3 because x cubed is your power function. So whenever degree is 3, the maximum turning point you have will be 2. According to the theorem, if degree is n, turning point will be n minus 1. So 3, you have 2 turns. All right, so look at the graph. Is it show 2 turns? Yes. First turning is here. Second turning will be here. So the graph showing 2 turns. So this is how you plot the graph. Okay.